Properties of exponents. The definition of an exponent is for any counting number n, b to the n power equals n factors of b. We refer to b to the n as the power, the nth power of b, or b raised to the nth power. We call b the base and n the exponent. For 3 to the 5th, the 3 is the base and the 5 is the exponent. That means I want to have 5 factors of 3, and that equals 243. In this example, we want to simplify a, parentheses, negative 2 to the 4th, and b, negative 2 to the 4th. This is not the same problem. Because of the parentheses in part A, our base is negative 2, so we have negative 2 times negative 2 times negative 2 times negative 2. So that gives us a positive 16. In part B, my base is 2. So I have my negative, and then I have 2 times 2 times 2 times 2. So that answer is negative 16. If the negative is a part of the base, you must have it in parentheses. Properties of exponents. If m and n are counting numbers, then b to the m times b to the n is equal to b to the m plus n. That's the product property for exponents. B to the m divided by b to the n equals b to the m minus n. If b does not equal 0 and m is greater than n, that's the quotient property for exponents. Parenthesis b times c, close parenthesis to the n, is equal to b to the n times c to the n, raising a product to a power. Parenthesis b divided by c, close parenthesis to the n, equals b to the n divided by c to the n, where c does not equal 0, raising a quotient to a power. Parenthesis b to the m power, close parenthesis to the n power, is equal to b to the m times n power. And that's raising a power to a power. In this example, we want to simplify 3b to the 4th, c to the 5th, times 5, b to the 6th, c to the 3rd. So for this problem, multiply the things that are the same. I want to multiply 3 times 5, which is 15. Then I want to multiply b to the 4th times b to the 6th. Because I'm multiplying the variables, I can add the exponents, and that gives me b to the 10th, because 4 plus 6 is 10. Then I want to multiply my c's, c to the 5th times c to the 3rd, and that gives me c to the 8th, because 5 plus 3 is 8. So my answer is 15, b to the 10th, c to the 8th. In this example, simplify 3b to the 7th, c to the 6th, divided by 12b squared, c to the 5th. For 3 divided by 12, that reduces to 1/4. b to the 7th divided by b to the 2nd, I can subtract the exponents. 7 minus 2 is 5, so that gives me b to the 5th. For my c's, c to the 6th divided by c to the 5th, subtract the exponents. 6 minus 5 is 1, which is just c. So my final answer is 1/4 b to the 5th, c. In this example, we want to simplify parenthesis 2, b to the 2nd, c to the 3rd, all to the 5th power. So the 5th power is distributed through my parenthesis, so I have 2 to the 5th power. b to the second to the fifth power, multiplying, that gives me b to the 10th. Then I have c to the third to the fifth power, multiplying, that gives me c to the 15th. 2 to the fifth power is 32. So my final answer is 32, b to the 10th, c to the 15th. If you're unsure what 2 to the 5th power is, you can go to our calculator. We want 2 to the 5th power, so you type in your 2. Then you use the button that looks like a little rooftop, your caret. Then type in your power, which is 5. Enter. And that's how we get our 32. In this example, simplify, parenthesis, 24b to the 7th, c to the 8th, divided by 16, b to the 2nd, c to the 5th, all to the 4th power. Follow order of operations. Simplify your parentheses, then the exponent. While 24 and 16 don't divide evenly, both 24 and 16 have a factor of 8. So if I cancel out the 8's, 24 divided by 8 is 3. 16 divided by 8 is 2. b to the 7th divided by b to the 2nd, 7 minus 2 is 5. c to the 8th divided by c to the 5th, 8 take away 5 is 3. And that's all still to the 4th power. I have 3 to the 4th power. I have 2 to the 4th power, b to the 5th to the 4th power, which is b to the 20th, and c to the 3rd to the 4th power, which means I have c to the 12th. 3 to the 4th power is 81. 2 to the 4th power is 16. So my final answer is 81 over 16 times b to the 20th times c to the 12th. Simplifying exponents. Simplifying expressions involving exponents. An expression involving exponents is simplified if it includes no parentheses, each variable or constant appears as a base as few times as possible. For example, we write x squared times x to the 4th as x to the 6th. Each numerical expression, such as 7 squared, has been calculated and each numerical fraction has been simplified. Each exponent is positive. When you see simplify in the directions, these 4 things need to have been done for your answer to be completely simplified. Exponents. Definition: zero exponent. For b not equal to 0, b to the 0 power equals 1. So let's say you have x to the 3rd over x to the 3rd. If we were to reduce this fraction, I could cancel 1 pair, 2 pair, 3 pair of x's, which leaves us with an answer of 1. Using our new rules, if I'm dividing like bases, I could subtract the exponents. 3 minus 3 is 0. If 1 equals x to the 3 divided by x to the 3, and x to the 3 divided by x to the 3 is equal to x to the 0, x to the 0 has to equal 1. Anything to the 0 exponent will equal 1. Negative integer exponent. If b does not equal 0 and n is a counting number, then b to the negative n is equal to 1 over b to the n. In words, to find b to the negative n, take its reciprocal and switch the sign of the exponent. This only works for exponents. So if I have x squared over x to the fifth, and I cancel two pairs of x's, then I'm left with 3 x's in the denominator. Using my rule of exponents, I take the top number, subtract the bottom number when you're dividing like bases. 2 minus 5 is negative 3. X to the negative 3 is the same as 1 over x to the third. In this example, we want to simplify x to the third divided by x to the fifth. 3 minus 5 is negative 2. To truly be simplified, we cannot have negative exponents. Flip it, and my answer is 1 over x squared. Negative exponent in a denominator. If b does not equal 0 and n is a counting number, then 1 over b to the negative n equals b to the n. In words, to find 1 over b to the negative n, take its reciprocal and switch the sign of the exponent. In this example, simplify 9b to the negative 7. Because there are no parentheses, the only base to the negative 7 is the b. 9 is to the first power. So 9 stays in the numerator. B to the 7th goes to the denominator. So my answer is 9 divided by b to the 7th. In this example, simplify 3 divided by b to the negative 5. The 3 has a positive exponent, so I don't move it. B to the negative 5, I've got a negative exponent, so I move it from the bottom to the top, b to the 5th. So my final answer is 3 times b to the 5th. In this example, simplify 6 times x to the negative 9 times y to the 4th, in parentheses, times, in parentheses, negative 2 x to the 5th, y to the negative 3. My first step is to multiply. 6 times negative 2 gives me negative 12. Y to the negative 9 times y to the 5th. Negative 9 plus 5 gives me negative 4. So I have x to the negative 4. Y to the 4th times y to the negative 3. 4 minus 3 is 1. So I have y to the first. And now I'm ready to deal with any negative exponents. I have a negative 12, but that exponent is a positive 1. So it stays in the numerator. X to the negative 4, negative exponent, so x to the 4th moves to the denominator. Y to the first has a positive exponent, so y stays in the numerator. My final answer is negative 12y divided by x to the 4th. In this example, I want to simplify a to the negative 7 divided by a to the negative 2. How you want to approach this problem depends on how comfortable you are doing math with integers. Using the rules of exponents, I need to subtract negative 7 and negative 2. So that would be negative 7 minus a negative 2, which is the same as negative 7 plus 2, which is negative 5. So that would give me a to the negative 5. Flip it, I have 1 over a to the 5th. If you're not comfortable subtracting integers, we have a second way we could work this problem. First, get rid of all the negative exponents. So what that will do is move my a to the negative 7 from the numerator to the denominator, and my a to the negative 2 from the denominator to the numerator. So I have a to the 2nd over a to the 7th. 2 minus 7 is negative 5, which is 1 over a to the 5th. Another way to look at this, I have a squared over a to the 7th. 7 is bigger than 2, so my answer of 5 will be in the denominator because a to the 7th is in the denominator. And that will allow you to skip your middle step here. In this example, I want to simplify 18b to the negative 5, c to the negative 4, divided by 27, b to the 3rd, c to the negative 6. Starting with 18 over 27, that reduces to 2/3. I can divide 9 out of both of them. For b to the negative 5 over b to the 3rd, I want to subtract their exponents. Negative 5 minus 3, which is negative 8. So that gives me b to the negative 8. Then c to the negative 4 divided by c to the negative 6. I have negative 4 minus a negative 6, which is negative 4 plus 6, which is 2. So I have c squared. Then making sure I have positive exponents. C squared is positive, so I have 2c squared on top. 3b to the 8th on bottom. My final answer is 2c squared divided by 3b to the 8th. In this example, I want to simplify in parentheses 16b to the negative 2c times parentheses 25b to the 4th c to the negative 5 divided by in parentheses 15b to the 5th c to the negative 1 parentheses 8b to the negative 7 c to the negative 2. By order of operations, my first step is to multiply. So 16 times 25 gives me 400. B to the negative 2 times b to the 4th gives me b to the 2nd. C times c to the negative 5 gives me c to the negative 4. Divided by 15 times 8 is 120. B to the 5th times b to the 7th leaves me with b to the negative 2. C to the negative 1 times c to the negative 2 leaves me with c to the negative 3. It's tempting to cancel our b's at this point, but b squared and b to the negative 2 are not exactly the same, so we can't cancel them. We do need to reduce. If you're uncomfortable reducing 400 over 120, you can use your calculator. Type in 400 divided by 120. Go to your math menu, choose one frac, enter. Enter again, and you have your reduced fraction of 10 over 3. Dealing with my b squared divided by b to the negative 2, remember that is 2 minus a negative 2, which is the same as 2 plus 2, which is 4. So I have b to the 4th. Now I want to deal with my c to the negative 4 divided by c to the negative 3. So I have negative 4 minus a negative 3, which is negative 4 plus 3, which is negative 1. So this means my b to the 4th stays in the numerator, and my c to the negative 1 joins my 3 in the denominator. My final answer is 10b to the 4th divided by 3c. In this example, I want to simplify parentheses 7b to the fourth c to the negative 5 divided by 14b to the seventh c to the negative 2, all to the 0 power. The trick to this one, anything to the 0 power is 1, even a parentheses. My answer is just 1. Definition of an exponential function. An exponential function is a function whose equation can be put in the form f of x equals ab to the x, where a does not equal 0, b is greater than 0, and b does not equal 1. The constant b is called the base. In this example, simplify. For f of x equals 3 parentheses 4 to the x power, find f of 2. So for f of 2, everywhere we see an x, we're going to put 2. So I have 3 parentheses, 4 close parentheses to the second power. 4 squared is 16. 3 times 16 is 48. F of 2 equals 48. When I have an input of 2, I have an output of 48. Scientific notation. A number is written in scientific notation if it has the form n times 10 to the k, where k is an integer and either negative 10 is less than n is less than or equal to negative 1, or 1 is less than or equal to n less than 10. What this means is when you're writing scientific notation, the first number should be a decimal with only a ones place in front of the decimal. 9.8 would be acceptable. 99.8 would not. Converting from scientific notation to standard decimal notation. To write the scientific notation n times 10 to the k in standard decimal form, we move the decimal point of the number n as follows. If k is positive, we multiply n by 10k times, hence we move the decimal point k places to the right. If k is negative, we divide n by 10k times, hence we move the decimal k places to the left. In this example, I want to write the following number in expanded notation. 3.638 times 10 to the ninth. The number is written in scientific notation. We only have a ones place in front of the decimal, and it's always times 10 to some power. We use the x because that's just how you write scientific notation. Because 9 is positive, what I want to do is take my decimal point and move it 9 places to the right. Any extra places we want to fill in with zeros. So my answer, 3,638,000,000. In this example, write the following number in expanded notation. I have negative 5.86 times 10 to the negative 12. Because the 12 is negative, our answer is going to be a decimal. We want to move our decimal point to the left. I'm going to ignore the negative for just a minute. I want to move my decimal 12 places to the left. So for my final answer, I have 0.000000000586. Converting from standard decimal notation to scientific notation. To write a number in scientific notation, count the number of places k that the decimal point must be moved so the new number n meets the condition -10 less than n less than or equal to -1 or 1 less than n less than 10. If the decimal point is moved to the left, then the scientific notation is written as n times 10 to the k. If the decimal point is moved to the right, then the scientific notation is written as n times 10 to the -k. If you have a decimal, you're going to use a negative exponent. If it's not a decimal, you use a positive exponent. In this example, write the following number in scientific notation. In 2005, there were 25 million households with digital video recorders. This is the number that we're going to be changing to 25 million. We start off by writing 2.5. You only want one number in front of the decimal point. Then we write our x in 10. This is going to be a positive exponent, but I need to figure out how many places. Seven. So 25 million can be written as 2.5 times 10 to the 7th in scientific notation. In this example, we want to write the following number in scientific notation. The diameter of a human hair is about 0.00254 centimeters. We only want one number that's not a zero in front of the decimal, 2.54, x, 10. This time we're dealing with a decimal, so our exponent will be negative, and I'm moving it 3 places, so I use 3 for my exponent. So 0.00254 can be written in scientific notation as 2.54 times 10 to the -3. When we have exponential notation in our calculator, it looks very different than what we're used to. So we type in a really big number. So when it gives us exponential notation, you have this e. When you write this number on your paper, it would be 1.2 times 10 to the 13. So the e is telling you the exponent you want for the 10. So let's say we had a really small number. Again, behind the e is your exponent. So this would be written as 4.56 times 10 to the -15. Now let's say you want to type in scientific notation. Let's say that our number was 2.5 times 10 to the 15. The way you would type that, you do the 2.5 as usual, then right above your comma is EE. So we do second, comma, and then you just type your exponent. They use the double E to distinguish it from the letter E that is used in some programming for the calculator. Properties of exponents. If you're multiplying like bases, you can add the exponents. If you're dividing like bases, you can subtract the exponents. If you have an expression in parentheses with an exponent on the outside, the exponent goes to everything in the parentheses. And if you have a base to an exponent that is in parentheses to an exponent, we multiply the exponents. Any base to the 0 power is equal to 1. Anytime you have a negative exponent, you make it positive by flipping the exponent. An exponential function is f of x equals a b to the x power, where only b is to the x power. With scientific notation, you want it in the format of 2.5 times 10 to the 5th or 2.5 times 10 to the -5th. If the exponent is negative, it's going to be a decimal. If it is not, it's going to be a whole number.